Hello everyone, and thank you for tuning in to my talk, Modern Technology and RegOps, Connecting the Dots. My name is Robert Binder, and I'm working at BearingPoint RegTech as the Associate Product Manager of Abacus Regulator. This talk is a follow-up talk to the RegOps talks by my colleagues Daniel Münch, Erik Becker and Laura Sostrate. As the title already implies, it focuses more on the technological aspects of RegOps, which we will dive deeper into during the talk. One of the most important points of this talk already comes in the second slide, namely that the implementation of RegOps is held back by policy, governance, and legal issues, but not by the available technology. Actually, the required technology is already available as we speak, and I will detail on that in the following. But first, let us get back to a slide of my colleague Daniel Münch, who introduced the 3 pillars of RegOps. The first pillar is a Common Granular Data Dictionary, or CDD. This data dictionary is something like a shared language between supervised entities and national and supranational competent authorities. The CDD is based on a granular level, that is contract partner or cash flow level. From this granular level, regulatory results of interest can be calculated using a common regulatory processing logic which is standardized between supervised entities and national competent authorities. The second pillar of RegOps is an end-to-end decentralized integration of both sides via an API-enabled solution. In this way, the national competent authority is able to disseminate regulatory logic such as transformations or the CDD itself to the supervised entities in an automated and streamlined fashion. In the other direction, the supervised entities are then able to push regulatory information on a granular level back to the national competent authorities. This API-enabled solution, of course, needs to exhibit flexibility regarding the different landscapes that the regulators face, for example, IT landscapes, legal frameworks, and so on and so forth. The third pillar is a big data-enabled tech backbone. So, because RegOps gives regulators access to more granular data than ever before, regulators have to be able to process this granular data. Therefore, new technology is required. And this technology, of course, needs to enable regulators both to work with the existing regulatory frameworks and to be future-proof for the application of new technologies and new regulatory requirements. Of course, the platform should also be able to enable regulators to use this new wealth of data for analytical purposes and business intelligence as well. So let's get back to the first pillar of RegOps, and this is the Common Data Dictionary, so the unified language both sides of the market speak. So what are the challenges and requirements for this Common Data Dictionary that arise from RegOps? So, as I already have said, regulators and supervised entity need to speak the very same language of granular data, and this language needs to be implemented in the CDD. The CDD should cover existing national and supranational reporting requirements, such as COREP or RTF, for example, in order to avoid redundant data collection and also to allow exchange of data between different NCAs across borders. The CDD should also be able to cope with evolving reporting requirements. That means that it should both cover the most important data points for prudential reporting in general, but should also be able to cope with regulatory change by incorporating, for example, national or new supranational extensions. Currently, there are a few common data dictionaries in development by different stakeholders in the market. For example, the ISTA Common Domain Model, Swift Unify MT, or ESCB BERT and IREF. However, these projected CDDs typically cover only specific use cases, and we strongly believe that these are at the moment still too narrow for generalized regulatory reporting under our projected RegOps scheme. Also, these CDDs do not include machine-readable descriptions for standard data transformations, for example, from granular data to CORIP. This puts the burden of implementing these transformations again on regulators or software solution providers, and bears the danger that during this implementation there are misunderstandings or transformations are implemented incorrectly. However, next to these projected CDDs, there are solution providers in the market which have for their own solutions over time developed comprehensive internal data dictionaries, which could be something like hidden champions in the market. For example, here at BearingPoint RegTech, for our Abacus product line, several thousand person-years have been invested in the internal data dictionary, and we believe that it is very comprehensive already at the moment. So what is the future outlook for CDDs in the market? So the first standard setters are experimenting with, and some are already adopting, like the ISTA, and together with digital asset, new technologies such as the distributed ledger technology. However, we believe that for broad adoption, a CDD would need to be open, that is accessible to all market participants, to avoid vendor login and to foster innovation. Also, due to the ongoing globalization of the financial sector, the CDD should not be a national one, and probably not even a European one, but it should cover at least the most basic regulatory requirements across the whole globe. And it should offer extensibility and flexibility regarding extensions, also, let's say, in at the moment underserved markets. And preferably, a CDD should be endorsed by influential standard setters like the BIS or EBA. And to be honest, we really believe that without such an endorsement, without a standardized CDD for, let's say, at least a large chunk of the international markets, the complexity of the market or the financial sector cannot be really reduced. So we really hope that there will be a CDD which is globally or at least European-wide adopted in the near future. However, the CDD is not really enough. As I have mentioned, the CDD is on a granular level, but of course you do not want to work on granular data all the time. You need to have more aggregated and refined data, which is more concise and more descriptive. To this end, you need to somehow transform this data. And under the RegOps scheme, this data transformation should cover both existing national and supranational reporting requirements, so that you can, for example, generate COREP reports out of it. But it should also, of course, cover all of the ad hoc requests that are the actual superpower of RegOps. So the possibility to get the information that you're actually looking on the fly from the financial sector. So to this end, these transformations need to be defined by business users, and in the most positive case, in an agile and lean fashion. That means that the transformation should not be, the language for that should not be too complex or, let's say, only available or only understandable by real experts. Second thing is that because you cover now the whole financial sector with these requests, probably ad hoc requests, they need to be carried out in a massively parallelized fashion. So let's say old software architectures might be overwhelmed by that. But there is a positive aspect here, namely that all of these challenges and requirements can be overcome as we speak. So our first, let's say, core idea or key message here is that we believe that we need to adopt a common standard for data transformation, such as, for example, SQL, that would allow business users to leverage the knowledge which is already in the market or already at the regulators to create flexible, powerful, but also reusable transformations which are nonetheless tailor-made for the requirements that they actually serve. So, for example, these are ad hoc requests. The CDD should, in our opinion, also include machine-readable prescriptions for standard transformations, for example, for existing national or supranational reporting requirements. In this way, we would make implementation or manual implementation of this redundant and would reduce the effort of all players in the market considerably. And to be able to access execute all these transformations in a meaningful sense, we would have need, of course, the third pillar of RegOps, namely the big data-enabled tech backbone that I will discuss at a later point during this presentation. So the second pillar of RegOps is integration via API. As I've already mentioned, APIs here fulfill the purpose of integrating both sides of the market, namely supervised entities on the one hand and regulators on the other hand. So it is a way to exchange information. And this information exchange should be, of course, well defined. But for RegOps to really flourish, it should also be open, because if it would be set up on proprietary or, let's say, hidden standards, you would have a vendor lock-in and there would only be a single market participant actually. So by going to open application-to-application interfaces, everyone can compete for the most innovative and most performant and most user-friendly solutions out there. That in order to make this actually work, you of course need to have up-to-date documentation of these APIs in the market so that all market participants know actually how the system of information exchange works at all times. And because these APIs are also exposed to the internet, you need to really adhere to the best practices regarding security and auditing. But also here, technology is already ahead of RegOps implementation programs. So as we speak, RESTful APIs and GraphQL APIs are the de facto standards for open A2A interfaces. And there's ample software support for that. And there's also quite some knowledge regarding that in the industry. And fortunately, there are also meta languages such as Swagger, OpenAPI, or GraphQL Schema, which allow for the creation of machine-readable API documentation and also for automated discovery of API-based services. That means that you do not need to handwrite documentation about the APIs that other people need to read and then implement into code, but you write, but the documentation is written automatically from the API that you have coded, and you can make this automated documentation available to someone else who can then machine-readably translate it directly into his or their services. Also, there are at the moment available, as we speak, modern distributed API gateways, for example, KrakenD, which allow for scalability, load balancing, as well as unified security and auditing policies. Let's say out of the box. You of course need to have expertise in that, you need to know what you're doing, but all of the technological backbone stuff, it's already in the market. The second thing about APIs is not only that they connect people, but which information they exchange. Of course, we have talked about the information in the CDD, the granular level deal information that is exchanged, but here we also need to exchange something else, namely the regulatory logic from the regulator to the market participants. And here we see, or we believe, that this regulatory logic in the RegOps context is nothing else than program code. So here, templates, validation rules, filing rules, things like that are just program code. Therefore, we believe that regulators have to acquire in the midterm expertise in functional software development in order to create and maintain this regulatory logic in an agile manner if they want to do it by themselves. And they can do it by themselves if they want to, or they should even do it by themselves. This regulatory logic that is created by the regulators, of course, needs to somehow end up at the supervised entities. And this should be as seamless as possible, preferably via the API-based infrastructure that we have set up there. We have also need to implement explicit version control. So, for example, there could be different versions of reporting modules or ad hoc requests, and market participants need to understand where the differences are and where the changes stem from. But also here, technology is already available. So Git has already become the de facto standard for version control in software development, and we believe that it is equally suitable for the development of regulatory logic. We at BearingPoint RegTech are actually implementing regulatory logic, for example, from the EBA or IOPA using Git as we speak. Git repositories have also turned out to be very efficient and easy to use ways to disseminate regulatory logic and updates to regulatory logic via A2A interfaces. For example, GitHub, one of the largest platforms for Git-based software exchange in the world, connects developers across the globe with users in a streamlined fashion. And we think that a very similar approach would be best suited for RegOps. This is all held together by modern DevOps suites such as GitLab, which enable regulators to harness the whole powers of agile software development and to adopt the best practices of the industry, for example, code reviews. Which validation rules have changed? What was the reason for that? Was this executed correctly? But also automated testing and continuous integration and deployment, which, for example, allows for the creation of automated test instances where you can check back if your new ad hoc request was actually implemented successfully before you hand it over to the productive environment and to the other market participants. And we strongly believe that only adopting this, what we call software factory, so this way of creating content, already fulfills more than 30% of most innovation agendas of regulators that we see in the market. The third pillar of RegOps is the big data-enabled tech backbone. As I have already mentioned, with RegOps, there is a deluge of granular data that is going to be received, validated, processed, and transformed by regulators. And although RegOps will agilize the regulatory value chain, there will still be peak periods. For example, you have just issued an ad hoc reporting request, and this ad hoc reporting request is now answered by the market. You will have a lot of data in a short time frame, and you need to cope with that data, and their performance and scalability are crucial. Out of these peak periods, of course, you do not want to have RegOps solutions to occupy your computational resources all the time continuously, but you want to have them scale up and down automatically as needed, and we call this elasticity. Here, again, modern technology is already ahead. Modern modular software architecture packages program functionality, for example, validation of input or transformation of granular data into autonomous containers, for example, using the de facto standard Docker. These autonomous containers can be deployed in parallel and communicate in a well-defined fashion. Then, container orchestration managers, such as again a de facto standard called Kubernetes, spawn and despawn these containerized processes as needed, and in this way allow for nearly unlimited horizontal scalability and elasticity. For example, if you want to do 100 transformations at the same time, Kubernetes would just spawn 100 containers for transformation. These would work in parallel and then would shut down automatically afterwards. Such architecture has often been dubbed cloud native. This is because it lends itself to the deployment in the cloud, because if you want to cope with peak periods, you could, of course, buy a lot of computational resources and put it into your server area at the regulator. But then, if there is no peak period, most of that would be idle. If you go to the cloud, you could just acquire and deacquire the computational resources as they are needed. And for good solutions, they should support most, or better even all, cloud providers which are out there in the market. That could be Amazon, Microsoft, or even nascent cloud providers like Gaia-X. Of course, such software solutions should also support private clouds at the regulators, where governance and policy makes going to the public offerings difficult or impossible. But of course, you do not only need to scale and be elastic, you also need to store large amounts of data, and access to these data amounts should be fast and efficient. And what we already see in the market is that also with classical regulatory reporting scenarios, relational databases have often become bottlenecks. And these bottlenecks, of course, need to be avoided in RegOps when you go to even larger data amounts. Also, you should not distribute the data of RegOps across different silos that adhere to different storage formats, but you should, if you implement this, make data available from a single point of truth. And this data in the single point of truth should also not be locked away in a proprietary storage format, but it should be freely available to external software solutions, for example, for business intelligence, or if you just want to disseminate the data to external stakeholders. So we here suggest going away from classical relational databases to modern distributed non-database storage formats, such as Apache Parquet. They allow for both massively improved parallel performance and compression. Why is that? So instead of a single monolithic database, what you now have are a multitude of individual files. And if you want to access the contents of these files individually, you can do so in parallel without hitting this bottleneck problem. And compression arises therefore that most of these formats are now column-based. So in a classical database, you have a row where you have different things, namely, for example, name of a counterparty, cash flow, and so on, very different things. In a column-based format like Apache Parquet, the storage is, for example, along, let's say, an interest rate. And this, of course, will also only be a number. And therefore, you can compress with the knowledge that there is just a number in this column. And also, there will be redundant data because, for example, for different counterparties, you have the same interest rate. Of course, these different files need to be packaged somehow. So you need to access them in a coherent way. So first they are stored, for example, using Amazon S3 or the compatible solution MinIO. When you have stored them, you need a data warehousing solution such as Apache Hive that then unifies these data sources into a cohesive data lake. But of course, you do not want to only have the data, you want to access it. And solutions such as Presto now create an SQL query layer on top of that data warehouse, which now allows you to access the data in your data lake as if it were in a standard relational database. And via this SQL layer, you can query the data, and also you can query it from external solutions like BI solutions, or you could make it available to dedicated APIs. The third necessity for a software solution for RegOps is adaptability and extensibility. So we see that the financial sector changes in a fast pace, and regulatory reporting requirements do so as well. And this makes regulators need to adapt to that change as well, and software solutions for regulators need to adapt to this change as well. And we see that classical monolithic software architectures, also bespoke ones created specifically for regulators, are not able to cope with these change and the fast pace of this change anymore. So this is one thing that needs to be taken in mind. The other thing is that the market is strongly shifting to risk-based supervision and AI and machine learning projects. And these cannot just be tackled by a one-size-fits-all approach where you have one standard software solution which does it all for everybody. Nonetheless, of course, you need the expertise to set up all of this, but the requirements are so very different, a monolithic architecture won't do it anymore. And therefore, we strongly believe that you also need to go to a modern modular software architecture founded on containerized functionality, where you can just create an additional container which plugs into your platform and communicates with the rest of the containers in a well-defined fashion, and thereby creates bespoke microservices to the very needs that you have. Of course, also business workflows will change. And there we think you should adopt modern business process model and notation 2.0 compliant solutions, for example, Camunda, which allow for agile changes and extensions to the workflows. So business workflows are not hard-coded anymore, but they are just software artifacts that can be changed at will. Modern programming languages such as Python, but also Java or C# offer then content creators lower barrier entry for creating custom content, for example, bespoke microservices. And there also is a multitude of readily available libraries, for example, for AI and machine learning projects by SciPy or Scikit available in the market. The DevOps solutions that we mentioned earlier to keep track and keep together your regulatory logic can also help you to keep together your custom extensions or bespoke microservices. So the same software factory that you use for creating and disseminating the regulatory logic can be used for housekeeping for your custom content and to make both of these parts fit together. When you now have all the data, you want to learn something from it. So RegOps is not an end in itself. You do not do RegOps just for RegOps. You want to have more timely, more comprehensive and deeper insights in the financial sector via advanced analytics. RegOps gives you the data, but you now need to analyze it. And therefore, RegOps solutions should make available all this data stored in their data lakes to proven external tools for business intelligence and data science. So we have seen a lot of solutions, and make it yourself is often a very bad idea. There are proven solutions in the market, Power BI, SAS or Tableau. You should not force users into your new business intelligence solution for RegOps because it will be probably worse than all of what is currently in the market. You should allow users to use the software that they actually like and work with all the time. Also, this lowers the entry barrier for analytics users for RegOps considerably, of course. The data which should be made available should be all the data in the data lake, actually. It should be the metadata from the data collection process. For example, if you want to do data quality analysis. It should be the raw and aggregated prudential and statistical fact data, for example, for KPIs and KRIs. And it should be also the data generated by bespoke functionality, for example, from AI and machine learning projects. You can, of course, include in your RegOps solutions lightweight internal tools, for example, Apache Superset for a first glimpse on the data or for data quality trends. For example, Apache Superset allows you to create dynamic dashboards to see who reported and which validation rules failed on a glance without needing to fire up Power BI and go to, let's say, the higher level or more complex analytics stack. With Presto, the component that we introduced earlier, or similar SQL query layers, you can then make the data in the data lake accessible to your outside BI solutions or also data science solutions, for example, like R, for advanced analytics. And because you do not want to work on the granular data or pre-aggregated data anymore, also there can be SQL views which are directly based on the CDD, which make work for analytics personnel much easier. Alternatively, of course, data can be made available via dedicated APIs, for example, for commercial BI connectors or other specific purposes. Such APIs can also facilitate dissemination of the data to external stakeholders or solutions. For example, you could just route data to real-time web applications, for example, for, let's say, insider trading reports, something like that. So I have now shown you all of the technology, but just be honest. Technology alone won't do the trick. You cannot just say, okay, I take all of this technology, bundle it together, and then I have my RegOps solution. That won't work. What you really need is you need to combine this technology with the know-how and the expertise in regulatory reporting. And you need to know what the market really needs. And what we did is we took several hundred of person years to create our new version of Abacus Regulator, which was devised according to these very principles I've presented you during this presentation. And at the moment, Abacus Regulator serves as the base for classical regulatory reporting solutions. But we intended it also as the technical foundation for RegOps. And we have just won the Central Banking FinTech and RegTech Global Awards 2020 with Abacus Regulator 3 as the cloud-native solution provider. So for going ahead to RegOps and for implementation of RegOps using Abacus Regulator. So I would like to thank you all for your attention. And if you have any questions, please come back to me with my email address posted on the top right of this slide. Thank you very much.